Saudi Arabia isn't just talking about a future beyond oil, it's already building it. While much of NEOM is still under construction or being reshaped, one project next door is almost finished. An $8.5 billion green hydrogen complex that's already over 90% complete. Wind turbines are spinning, solar power is online, the export ships are scheduled for 2027. In this video, we break down how this project actually works, why it's progressing faster than anything else in Saudi Arabia, and whether it can really replace oil as a global export. This project is officially called the NEOM Green Hydrogen Project, and it is being built at Oxagon, the industrial port city on the Red Sea. The location is the main thing here. This is not some random desert experiment. It is right on a major global shipping route, designed from day one to export fuel to the world. The company behind it is the NEOM Green Hydrogen Company, or NGHC. It is not owned by just one player, it's a three-way joint venture. NEOM itself is one part. ACWA Power, Saudi Arabia's renewable energy heavyweight, is another. And the third partner is Air Products, which is one of the biggest hydrogen companies on Earth. Each owns exactly 1/3. No loose control, no side projects, everyone is locked in here. Now this is where you understand the scale of this project. This is not a pilot project or just a test plant. When it is fully online, this facility will produce up to 600 tons of carbon-free hydrogen every single day. That hydrogen doesn't leave the site as gas. It gets converted immediately into green ammonia because ammonia is easier to ship long distances. Over a full year, that adds up to 1.2 million tons of green ammonia, exported straight from its own purpose-built port. And yes, the money behind it is just as serious. Financial close happened in 2023, with total funding at around $8.5 billion. More than $6 billion of that came from a massive non-recourse loan backed by over 20 international banks and Saudi financial institutions. That only happens when lenders believe the project will actually deliver. Now pause here, because this is important. A lot of projects in Saudi Arabia are still ideas, renders, or early construction. This one is different. By late 2025, construction crossed 90% completion. Wind turbines were delivered and installed, electrolyzers are on site, hydrogen storage vessels are in place, pipe racks, cold boxes, transmission lines, all are already standing in the desert. So why did this one move so fast? Part of the answer is that this project had one very clear job from the start. The goal is to make green hydrogen at scale, convert it to ammonia, and ship it out. Another reason is the location itself. NEOM sits in one of the best renewable energy zones on the planet. Strong desert sun almost every day. Consistent coastal winds are off the Red Sea. That combination allows renewable power to run nearly around the clock. This is exactly what hydrogen production needs to be economical. And then there is the buyer. Air Products is the exclusive off-taker for everything this project produces. Every ton of green ammonia, locked in under a 30-year agreement. That single detail changes everything. It removes market uncertainty. It guarantees revenue, gives banks confidence, and explains why this project didn't stall the way so many megaprojects do. While other parts of NEOM are still negotiating purpose and identity, this project already knows who it's serving, how it gets paid, and where its product goes. By the time renewable power assets finish up in mid-2026, the project will shift from construction into commissioning. That's the most dangerous phase for any megaproject. Systems have to talk to each other. Power flows must stabilize. Equipment has to run non-stop, not just look good on site visits. And yet, if everything stays on track, the first green ammonia will leave the port in 2027. Now, understanding why this project matters requires looking inside how this machine actually works. At its core, the NEOM Green Hydrogen Project is a giant energy conversion machine. Everything starts with electricity. Not fossil fuel electricity, not grid electricity. On-site renewable electricity, produced specifically for this facility. Spread across hundreds of square kilometers are massive solar farms and wind gardens. Together they generate around 4 gigawatts of power. That's power on the scale of a large national grid, dedicated to a single industrial site. A custom transmission network moves that electricity directly to the hydrogen plant. There are no middlemen, no external grid dependence. Once the power arrives, it feeds the heart of the system, the electrolyzers. Electrolysis is the process of splitting water into hydrogen and oxygen using electricity. The technology itself is not new. What's new is the scale. The project is installing over 2 gigawatts of electrolyzer capacity, making it one of the largest electrolysis deployments ever attempted. Water is sourced through desalination, treated and fed into the system. When renewable electricity passes through the electrolyzers, hydrogen is produced at extremely high purity. Oxygen is safely vented or reused. The hydrogen moves onward immediately. There is no long-term storage at this stage because speed matters. Next comes the ammonia step. Pure hydrogen is difficult to ship long distances. It is light, volatile, and expensive to transport. So NEOM does what the global industry already understands. It combines hydrogen with nitrogen to form ammonia. Nitrogen is pulled from the air using air separation units installed on site. Hydrogen plus nitrogen under pressure and heat becomes ammonia. This conversion step is critical. It turns clean hydrogen into a globally tradable product. From there, the ammonia is cooled, stored in massive tanks and moved through pipelines directly to the port facilities. The jetty was designed specifically for ammonia tankers. No retrofitting, no shared terminals. Ships dock, load and leave. This is where the integration challenge comes in. Each part of this system works on its own. Solar works, wind works, electrolysis works, ammonia synthesis works, shipping works. The real challenge is making all of it run together continuously without failure. That's why commissioning is the real test. Between 2026 and 2027, engineers will focus on system integration. This includes balancing renewable power, smoothing output with storage, testing safety systems, and running the plant not for hours but for weeks at a time. What gives this project an edge is experience. Air Products has decades of hydrogen and ammonia expertise. ACWA Power knows how to build and operate utility-scale renewable assets. And NEOM provides the infrastructure, port access, and political backing needed to move fast. If it works, this plant becomes proof that green hydrogen becomes a repeatable industrial model. And that's why the world is watching. Because if this system can ship millions of tons of green ammonia reliably, it doesn't just change Saudi Arabia's energy story. It changes how clean fuel is produced, priced and traded worldwide. And that's exactly why this project matters far beyond the desert where it's being built. If this project works the way it's designed to, it quietly rewrites the rules of clean energy. At full operation, the NEOM Green Hydrogen Project is expected to avoid around 5 million tons of carbon emissions every year. That's the equivalent of removing several large fossil fuel power sources from the system. And it does it without asking industries to slow down, shrink or compromise. The fuel still moves, the ships still sail, the factories still run, just without the carbon. That's the real shift here. Until now, green hydrogen has mostly lived in reports and pilot projects. NEOM is trying to push it into the same category as oil, gas and LNG. A globally traded commodity, produced at scale, shipped across oceans and consumed by industries that don't have easy alternatives. Shipping, steel, chemicals, fertilizers, heavy transport. These sectors cannot just go electric overnight. They need dense, transportable energy. NEOM's answer is green ammonia, produced in the desert and sent to markets that are already racing to decarbonize. Europe is one of them. Asia is another. Both regions have climate targets, limited renewable space, and growing energy demand. The site sits right between them, with direct access to global shipping lanes through the Red Sea. That geography is quite strategic here. And then there is the cost question. For years, critics said green hydrogen would always be too expensive, too complex, too fragile. The project challenges that idea by stacking advantages in its favour. Some of the world's cheapest solar and wind power, massive scale, guaranteed long-term buyers, and a fully integrated supply chain. If NEOM can produce and deliver green hydrogen at competitive prices, it puts pressure on every other clean fuel project on the planet. This is also where Saudi Arabia's strategy becomes clear. Everything is about future exports. Oil built Saudi Arabia's economy. Hydrogen could help extend its role in global energy without being locked into fossil fuels. NEOM is the test case. If it succeeds, it becomes a blueprint for dozens of similar projects across the kingdom. That's why this project sits at the centre of Vision 2030. It creates high-skill jobs, it attracts foreign capital, It builds industrial expertise that doesn't disappear when oil demand eventually falls, and it positions Saudi Arabia as a supplier of clean energy, not just a buyer of climate commitments. But none of this is guaranteed. NEOM isn't just betting on hydrogen, it's betting that the rules of global energy are finally ready to change. What we've seen here is not a concept, a render, or a promise. It's an $8.5 billion industrial system that turns sun and wind into exportable fuel, largely built, already financed, and already scheduled to ship by 2027. In my view, there is something profoundly significant about this project. While the world often dismisses mega projects as mere vanity, the NEOM Green Hydrogen plant is different, because it is built on the cold, hard logic of industry and guaranteed demand. It suggests that the transition to green energy won't happen through idealism alone, but through the same ruthless efficiency that once built the oil empires of the 20th century. So the real question is this: will projects like this quietly reshape global energy markets, or will oil remain dominant simply because replacing it is harder than we think? If you're interested in how architecture, infrastructure, and large-scale engineering are shaping the world around us, the Design Zip channel explores those stories in depth. And if you'd like to see more projects like this in the future, consider subscribing.